Okay, today we're going to talk about right triangle trigonometry. This should be stuff that you learned at some point in your math career, probably ninth grade, maybe before, maybe after. The Pythagorean theorem, does that sound familiar at all? Hopefully it does. Let me just remind you what it is. A squared plus b squared equals c squared. Okay, what does that mean? If you look at the triangle over here to the right, we've got a triangle. It's got A, B, and C in big capital letters. Those capital letters are talking about the angles. So this is angle A. This is angle B right here. And this right triangle corner, that 90-degree angle, is angle C. When we talk about the sides, we use lowercase letters. So I'm going to put A here and B here. Those are kind of interchangeable. It's the two of the shorter sides. And then the hypotenuse, this long side, is always C. So this Pythagorean theorem right here basically is an equation or theorem that helps us find one of the sides when they're missing. So let's look down here at example 1a. It tells us in this example that we have a right triangle. I'm going to draw one right here. Side A is 16. I'm going to put that on this side. We don't know what side B is, so I'll put just a B here. And then side C, the hypotenuse, is 20. So I have all that information. I need to find the missing length. So I need to find B. So I am going to plug in what I know into this Pythagorean theorem right here. So A is 16. So A squared, 16 squared, plus B squared, which I don't know what it is, equals C squared. And C is 20. So 20 squared. So from here, all you really have to do is solve for B. So let's do that. 16 squared is, let me do it in my calculator, 256. B squared, again, we don't know what that is. 20 squared is 400. Now I need to solve for B, so I need to get it by itself. So I'm going to subtract 256 from both sides. And so I'm left with B squared on that side. 400 minus 256 is 144. So now we know that B squared is 144, but we want to know just what B is, just what that length is. So in order to get rid of the squared, I need to do square root on both sides. That's like the opposite of squared. So square root of B squared is just B. Square root of 144 is 12. So that missing length right there is 12. One of them's 16, one of them's 12. The hypotenuse is 20. So we're going to do the same thing with B. If you want to pause the video right now and try it yourself, I think that's a great idea. I am going to go through it so you can double check that you know what you're doing. Let's draw a right angle triangle. Doesn't matter which way we put it as long as it's a right triangle. A and B are the two short sides on the side. So A, I will pick this side to be A. B is 5. And then it looks like C, the hypotenuse, is what's missing. So I need to find that. So again, I'm just going to plug them into the equation. A squared plus B squared equals C squared. So A is 3, so we've got 3 squared. B is 5, so 5 squared. And then C, we don't know. We need to figure out what C is. So let's simplify and solve. 3 squared is 9. 5 squared is 25 equals C squared. So I can add those two together. I get 34 equals C squared. Then we need to get C by itself, not C squared. So to do the opposite, I'm going to take the square root of both sides. C equals square root of 34. Weird number. Like if you wanted to solve down for the decimal, you could. You would get 5.83. You can also leave it like this, or you could try and simplify the radical. I don't think that this one simplifies at all. So I would be okay with this as your answer. You can ask your teacher if they prefer the decimal or whatever. But that's the basics of the Pythagorean theorem. Hopefully it comes back to you and you remember what's going on. Okay, so the next thing we're going to talk about is we're going to talk about trigonometric ratios. Basically, sine, cosine, tangent. Hopefully that sounds familiar to you. I think you did it last year in secondary math too. Sine, cosine, and tangent are just ratios. They're just something compared to something else. So let's talk about what they are. Sine is, well, okay, first let's draw a triangle so you can kind of see what I'm talking about here. So let's say we're going to focus on this angle. A lot of times we'll call the angle theta. So that's what this looks like, an O with a line through it. That's called theta. And that's what we use to describe the angle. So if we're talking about this angle here in the corner, theta, we can describe, we're going to use things like opposite, adjacent, and hypotenuse. Hypotenuse is always going to be this long side. It's always the longest one. Adjacent and hypotenuse will kind of change depending on location. So think about opposite being opposite of the angle. So if you look at theta right here and you go all the way across, the side that's across, not touching it at all, is what we call the opposite side. The side right next to it is the adjacent side, just like the word describes. So if we were to do another triangle here, oh, that's not a good right triangle, I apologize. If we were going to do another right triangle right here, and instead of using the angle in the corner, we were going to use this upper angle right here, theta. Hypotenuse will stay the same. It's still this long one. However, opposite is now going to be the one across, so now the one on the bottom. And adjacent is going to be the one right next to it here on this side. So you just kind of have to look at your angle to see what side is next to it and what side is across from it to find opposite and adjacent. Now these trigonometric ratios just are going to be comparing sides essentially. So the sine of theta is always going to be the opposite side divided by the hypotenuse. The cosine ratio is always going to be adjacent divided by hypotenuse. And the tangent is always going to be opposite divided by adjacent. To remember this, a lot of times we'll use I think the word's anagram. SOHCAHTOA, if that sounds familiar at all. So if you look over here at so this is sine equals opposite over hypotenuse. Ka is cosine equals adjacent over hypotenuse. And TOA is tangent equals opposite over adjacent. So if you ever need to remember what sine is, what cosine is, and what tangent is, SOHCAHTOA is helpful. So let's put that into practice here on example 2. So let's look at this first one here. We've got a triangle with sides 15, 17, and 8. Let's first identify the angle. So we're looking at theta right here. So that is the angle we're looking at. I hope from here you can see opposite is going to be this 8. It's going to be our opposite side. Hypotenuse is always this long side. And adjacent is this 15. That's the one that's right next to it. Okay, adjacent. So if we're going to find sine of theta, I know that sine equals opposite over hypotenuse. So opposite is 8. Hypotenuse is 17. There you go. That's your answer. You can write it as a decimal if you'd like, or keep it as a fraction. Just ask your teacher what they prefer. Cosine is adjacent over hypotenuse. So in this case, adjacent is 15. Hypotenuse is 17. That's your answer right there. Tangent is opposite over adjacent. So opposite is 8. Adjacent is 15. And that's what you should get. Now let's move over to the second example here on example 2. you may notice we are missing something right here. We don't know what the hypotenuse is. So we need to use the Pythagorean theorem to find the hypotenuse. So let's do that first part. So remember Pythagorean theorem, a squared plus b squared equals c squared. C squared is the hypotenuse. That's what we need to find. So a and b are 5 and 12. So let's plug those in. 5 squared, 12 squared, and we don't know what c is. So let's simplify. 5 squared is 25. 12 squared is 144. C squared, we don't know yet. 25 plus 144 is 169. So c squared equals 169. We want to find c by itself. We need to get rid of the squared, so we need to do square root on both sides. C equals 13. So now that we know that this side is 13, we can solve for sine, cosine, and tangent. I want you to notice again that our angle has changed. So right here is our new angle. That's where theta is. Wherever theta is, that's the angle we're talking about. So if that's theta, then opposite is going to be this side right here. That's the one opposite it. 5 is the adjacent one, the one right next to it. And then hypotenuse is always this long one. So as you're solving, if you want to, pause the video right here, solve for the next 3, and then come and compare that you're doing it right. I will put them in right here. So sine is opposite over hypotenuse. So 12 over 13. Cosine is adjacent over hypotenuse. So 5 over 13. And tangent is opposite over adjacent. So 12 over 5. Once you know what the sides are, and once you can figure out opposite and adjacent, it's not too bad. I hope that was helpful. Ask your teacher if you have any questions.